that unit. Otherwise, the moment you start the lube oil pump, boom, everywhere oil will come. So you make a tool and keep it on the shelf so that you can lock the oil inlet to that unit. Then you can do the pump manual starting and then do the injection. But if you put the piston, then it is okay. Then you can connect the lube oil line and then. Otherwise, lube oil will be only coming into the unit to the bearing and other. So we can do. Any questions on this now before we go next one? No questions? Good. Engine-driven pumps. So we have got engine-driven pumps here. There are two, three different kinds of pumps here. We have evolved from the first design to the last design to the present design. We've got mostly Bosch Rexroth pumps. And if you look at this here, that's a spline, which means the drive from the shaft coming in, chain or gear, whatever it is. And we've got the pistons, etc. here. And there is a nice movie on this, how these pumps will rotate in clockwise and anti-clockwise direction. It is already there on the Google, but of course, when you come to do the next course, you will get all the movies on the USB drive. But otherwise, you can actually look at the Google. Somebody has put it in the Google. ME engine hydraulic pump operation. Just type in that, you can get a YouTube. Okay, that's good actually. You can see how the shaft speed moving from 0 to -15 and also to the other side. Because it's a reversible pump, no? So we need to move it either side. So this is one direction. Now slowly come at the middle position when there is not enough oil required. Then it will move to the other side. And why these pumps have to be reversible pump? What is the reason? Why these pumps should be reversible?
Because when the main engine runs in the reverse direction, it should be able to supply the pressure.
Okay. Okay, let me just put a situation like this. Your electrical pump, what direction that will run all the time? Let us say clockwise direction. By mistake, the electrician connected the wire wrongly, so then that will go into anti-clockwise direction. Then what will happen to the pump inlet and outlet? This is, let me tell you, this is the most expensive mistake that you can make. What will happen to suction discharge?
So the direction will change, the suction discharge will change, interchange.
Then what will happen to the pump?
The supply will not be to the...
What will happen to the pump? What happened to the pump now?
It will damage the damage.
How much time that will run dry? How much time that will take to run the pump dry and damage it? I mean, how much time it will take to damage the pump? Anybody have got any guess? Anybody, any guess? How much time? I know, you don't guess. It will not take more than 30 seconds. Okay? That's all it takes. So you need to be extremely careful, not only here, any hydraulic pump running dry, it will become a molten metal, just like that. Okay? So there was a case, what is it called? The claim case on the pump failure. In Copenhagen, we have a pump which ran around not more than a minute. It is completely damaged. Yeah. So you need to be extremely careful. So now when the engine is running in astern, what happened? Directional rotation of the pump change, no? Astern meaning running the pump in anti-clockwise direction. The suction discharge will interchange. When the suction discharge interchange, what will happen? It will suck from here and discharge into this. Is that what we need? No. We need oil all the time going into your HE. Whether it's astern or ahead, we still need to inject the fuel. We still need to open exhaust valve, correct? Which means I need to have oil here all the time, whether you're astern or in ahead. So therefore, the moment you run the engine in astern, this fast speed what we see here has to go to the other side, minus 15%. That's the max. So what will happen? The suction discharge remain at the same. So this is why we use a reversible pump in the hydraulic system. But if you got a CPP, no worry. It will be only unidirectional. Same like your steering gear system, valve hydraulic system, or even your mooring windlass. They are all unidirectional. They only move from, they are like this. They only move from 0 to 15 degree max. But this will go 0 to 15 plus, 0 to 15 minus, both direction. So that is why we need to have a reversible pump. Okay, now coming back to the second law. We got a mechanism to change the swash plate angle. So that is there here. It's a slider spring. There is one valve here, big one at the bottom. This is we call them as a pilot valve. This pilot valve has to allow the oil to go here or here. Of course, this requires a lot of energy to move up and up. So somebody has to decide how much oil should go here and which direction the oil should go. Okay. So who decides this? There should be an electrical device which makes the spool to move this way or this way.
ACU, sir?
Yeah. So ACU 1, 2, 3 has got a channel which will generate either voltage or current. The newer designs, it is a 4 to 20 milliampere. Older design, it is plus 10 volt, minus 10 volt max. Okay. So that much current will come here with this little pilot valve. This will make the proportional valve move corresponding to the electrical signal that is coming here. So let us say I got a signal to get 57%, 70%, 30%, 25%, whatever. So that much correspondingly, that much current or electrical signal will come correspondingly to this little unit for proportional valve. So this will make the spool move correspondingly. Okay. So accordingly, the oil will come here, and then of course it will work with the spring. Then your angle will change. Now, two things that you need. One, we must know whether the angle is actually moved. Let's say this current, what is coming here, is corresponding to 7 degree, which is equivalent to 50% swash plate angle. So now, if you look at here, what we see here is only percentage of the swash plate angle. 15 is 100%. Of course, there is a mechanical stoppage there before 15 degree to stop. All right, coming back to this now. I need to have a feedback. So one feedback which actually tells whether it is actually moved to 50%. So that will come from this little feedback. This is a proportional inductive sensor. You can see a cut here, the inductive sensor here. So the moment the swash plate moves, this device also will move. It's just a little plate, and there is a V wedge kind of a thing. So it will show you how much is the movement. And we also need to know whether this pilot valve is moved correctly. So let us say corresponding to 7 volt, what is coming here, as it moves. So we also need to have a sensor for that. So there is a proportional valve feedback sensor. So this is the feedback for the proportional valve. So this is to activate the proportional valve, and this is to verify the proportional valve is moved or not correctly. So there is one feedback from here and one feedback. So let us say this ACU number 1 is failed. You got a red light. Then what will happen to this pump? Ideally speaking, this pump should go to 100% ahead direction. So what will happen to this guy? He will not get any signal. So the proportional valve will go to a default position, and this will go to 100%. And you cannot move this with your strong muscles. Okay, leave it like that at 100%. That's all you have to do. Nothing you can do. So, but still you got 2 more pumps. fillet oil is 2 bar, outlet is 300 bar. That's a control oil pressure. It is the same pressure of this, okay? And there is a drain from